Today we're going to take a look at the angles of polygons and the properties of those angles. So we're going to look at some important theorems about angles that are in polygons. We're going to end up with a formula that helps us with the sum of the interior angles. So that means like what they all add up to. And then we're also going to get a formula once we know what the sum of the angles are, to actually find the measure of each of those angles in a polygon. So before we begin, we need to go over a couple of terms. The first term I want to talk to you about is included side. So included side is going to be a side between two consecutive angles. So consecutive means that they're right next to each other. So for example, C and A are consecutive. So the included side would be side CA. Another term that's important to know is included angle, and that's going to be an angle that's in between two consecutive sides. And remember, consecutive means that they share a point. So consecutive sides would be like side ZX and YX. Those are consecutive sides, and the included angle would be angle X. All right, so now let's take a look at this really important theorem, which says that the sum of the measure of angles of any triangle is always going to be 180. That's helpful because if you're missing an angle, all you have to do is make sure that all the angles add up to 180. Another really important theorem is that if two angles of one triangle are congruent to two angles of another triangle, then those third angles will also be congruent. So, for example, if angle A is congruent to angle X and angle B is congruent to angle Y, therefore angle C also has to be congruent to angle Z. All right, our next theorem says that acute angles of right triangles are complementary. And remember, complementary means that they add up to 90 degrees. So the reason that is because if it's a right triangle, then that third triangle is 90. And if they add up to 180, 180 minus 90 is 90, which means those other two angles have to add up to 90, which is the definition of complementary. So if we want to find the total measure of the angles of a polygon, since we know that a triangle adds up to 180, all we have to do is take that polygon and make triangles out of it. We're going to subdivide the polygon into triangles. And once we do that, we count up the number of triangles and then multiply that by 180. So for this one, there were 5 triangles, so 5 times 180 is 900 degrees, which means that the sum of all the angles in this polygon is equal to 900 degrees. So the number of sides a polygon has, like this is kind of a chart that compares the number of sides to how many triangles it will have. So a polygon with 4 sides will have 2 triangles. A polygon with 5 sides will have 3 triangles. And so if you notice that there's a pattern that is developed. So it looks like depending on how many sides you have, the number of triangles is just 2 less. So if you have n number of sides, to find the number of triangles, you just do n minus 2. So let's look at an example. What is the sum of the measure of angles of a pentagon? And if the pentagon is regular, that means all the angles are the same. Find the measure of each angle. Well, we know a pentagon is 5 sides. And so if a pentagon is 5 sides, then the number of triangles it's going to have will be 3, because 5 minus 2 is 3. So we have 3 triangles times 180 degrees for each triangle, and we get 540 degrees. That is the sum of the measure of the angles. So now we want to know, well, how much is each angle? Well, if it's regular, that means each angle is the same. So if there's 5 angles in a pentagon, right, because there's 5 angles in a pentagon, then we'll just divide this 540 degrees by 5, and we end up with 108 degrees per every angle in the pentagon. All right, go ahead and take a look at the lesson in the textbook. Make sure that you copy down any additional examples and theorems that you might need and some pictures, and try some problems on your own.